All right, so good morning once again, everyone. Welcome to our class. Today we're going to study mirror equation. Okay, so in here, we're going to learn another way of describing the image. Okay, because last time we have learned how to describe the kind of the image using a ray diagram. Okay, so today we're going to use the mirror equation, right? Okay, so let's start now. Okay, so this is what we call the mirror equation. This is another way to predict the characteristics of the image beside ray diagram. Okay, so one way is to use the mirror equation to calculate the position of the image using this equation. Okay, we call this the mirror equation. Okay, so 1 over f equals 1 over dO plus 1 over di. Okay, whereas f is the focal length and then dO is the distance of the object from the mirror and di is the distance of the image from the mirror. Okay, very easy to remember, right? And then aside from this one, there's another equation that you need to remember. Okay, we call this the magnification equation. Okay, we use this to calculate the orientation and size of the image. Okay, when we say orientation, whether it is upright or inverted. Okay, and the size, whether it is enlarged or reduced. Okay, now we have this one, magnification equals m. Magnification is m equals negative di over do equals hi over ho. Okay, again, m is magnification, di is the distance of the image from the mirror, do is the distance of the object from the mirror, hi is the height of the image or the size of the image, and then ho is the height of the object or the size of the object. Okay, so you have here here is how this works. Okay, if we get a positive magnification, meaning when we solve this one and the answer is positive, the image is upright. Okay, meaning just standing upright. Okay, but if we get a negative magnification such as this one, negative 0.67 times, it means that the image is inverted. Okay, negative means inverted. If the magnification value is greater than 1, okay, the image is enlarged, of course. Okay, if the magnification value is less than 1, the image is reduced. Say, for example, 0.67 times is less than 1, therefore the image is reduced. And if the magnification value is equal to 1, it means that the image is the same size as the object. Okay, so using this one, we can say that if we have this value, we can say that the image is inverted and reduced, right? Now, also in solving for the mirror equation problem, we need to remember this sign convention. Okay, for focal length, can you read this rule for me, please? Captain number 1, for focal length, f is positive and negative when? Hello, Captain? Captain? Captain?
Yes,
Okay, Captain, can you read the rule for focal length? This one, number 1, please.
F is plus for convex mirrors
Okay,
and
and
F is minus for convex mirrors.
all right, thank you so much, Captain. Remember, okay, you should remember this one. In solving for mirror equation, 1 over f equals 1 over do plus 1 over di, the value of f is positive, okay, for concave mirrors. And the value for f is negative for convex mirror, right? How about magnification? Fluke, hello Fluke, can you read the rule for magnification of the mirror if you find these values? Fluke,
M
please.
is plus for upright images. M is Negative for inverted images.
All right, so that is correct. Okay, M is positive if you see an upright image, and M is negative for inverted. Let's say if this is an image, this value of M should be negative. All right, should be negative. All right, next, how about Chukun? Can you read the rule for image distance, please? Chukun, number 100. DI
DI is positive. It is positive.
Yes, positive, yes.
DI is positive for image in front of a mirror.
Real.
Real image. DI is negative for images behind the mirror visual image.
All right, thank you so much. Okay, now when you solve and you find this value, DI is positive for images in front of the mirror, right? Now, when we say the image is in front of the mirror, it means that it's real. Jamaica, if you can still remember, it's a real image. It is on the same side as the object. It means that it's real. Now, and if DI or the distance of the image is negative, if it is behind the mirror, okay? And when the image is behind the mirror, if you can still remember, it's virtual. Jamaica, it's virtual. Okay, next, Beam, can you read the rule for object distance, please, Beam? Hello, Beam.
Yes, yes.
Number 4, please. Rule for object distance. DO is
D0
DO
is this DO.
Okay.
DO is positive for object in front of the mirror or real image. DO is negative for objects behind the mirror or virtual image.
All right, that is the rule for object distance. Thank you so much, Beam. DO, or the distance of the object. DO means distance of the object. That is positive for objects in front of the mirror. Again, in front of the mirror, that is real images, right? Or yes. And DO is negative for objects behind the mirror or virtual images, right? So remember this rule. This is very important when we describe the image, right? Describe the image using the mirror equation. Okay, so let us proceed with the next slide. This one here, mirror equation. Assume that a certain, I think this is an example, okay, an example using mirror equation. Assume that a certain concave spherical mirror has a focal length, okay, focal length of, by the way, to know that, let's go back, okay. This one here, the distance from the center of the mirror or vertex from F going to F, this one is called F or focal length. Okay, F is focal length. This is the distance from F to the mirror. Okay, and this is F is 1/2 of the distance from the mirror going to the center of curvature. Okay, so this one is the radius, and F is 1/2 of the radius. Okay, remember that, don't forget. Okay, distance from C to the mirror is radius, and F is 1/2 of the radius, and that is the focal length. That's very important to remember that. All right, so next example, assume that a certain concave spherical mirror has a focal length of 10.0 centimeters. Okay, that is F. Okay, now what you're going to do is locate the image for an object distance of 25 centimeters and describe the image characteristics. Okay, so we as you can see here, we use the formula 1/F equals 1/DO plus 1/DI, where F is the focal length, DO is the distance of the object from the mirror, DI is the distance of the image from the mirror. So what are the given? We have F, okay? F is 10.0 centimeters here, equals, what else? DO is the object distance, okay? Or the distance of the object, which is 25 centimeters, plus 1 over di. Okay, so in solving this one, in using your mathematics, right? Get the LCD. How do we do that? 1 over di. Okay, tell me if I'm doing it correctly. Okay, 1 over di equals 1 over f minus 1 over do, right? Okay, so in other words, that is, this is 10, 1 over 10 minus 1 over 25. Okay, how do we solve this? We get the LCD. Check me up. LCD of 10 and 25. How's that? 50. 50. All right, 50 and 20.
5 minus 2.
Okay, so what's your answer, Churler? 5
3
minus
over
2.
50.
3 over 50. Okay, so di is equal to 5 minus 2. That's negative, right? Is that negative? No. That's 5 minus 2.
No.
5 minus
No,
2. Okay.
And just 3 over 50.
Okay, 5 minus 2 is 3 over 50. And 3 over 50, that is 1 over di. Sorry, this is d. Okay, d over equals 3 over 50. Okay, 3 over 50. Okay, so it means that di equals 50 divided by 3. Sum it up, 50 divided by 3. Okay, so 50 divided by 3 is something between 15 divided
Maybe
by
just
3.
16 to 17.
16. All right, 16. Let me, okay, 16. All right, 16.67 centimeter. Okay, so in here, what does this tell us? What does this answer or number tell us? First, we know the image is between C and F. That since the image distance is positive, therefore this is a real image. Okay, and then what else? What about the size and orientation? Okay, the size and orientation. How do we solve that? Okay, so for solving for the size and orientation of the image, we use the magnification equation. Okay, so this one is the mirror equation. Another one, to solve for the orientation, we're going to use the magnification equation. Let me proceed. Okay, using this one. Okay, answer for that is that again. Is this another di? Okay, so I think that's another problem. 10 centimeter, and then 5. All right, that's another problem. Okay, how do you solve for the orientation? So we're going to use m equals, we already have the value for do and di, so that is negative di over do. Okay, so di is we have negative 16.67, 16.67. Okay, bear with my mouse. And then do, what's do? That is 25. Okay, 25. do is 25. So that is 16.67 divided by 25. And let me use the calculator here. That is 16.67 divided by 25. That is 0. That on our example, that is negative 0.67. Okay, 0.67. Okay, 0.67. Oh, question. What is the size? Is it enlarged or reduced? We have m is negative 0.67. Is it enlarged or reduced? M equals
Reduce.
reduce, okay, because it is less than 1, okay?
Negative.
Negative.
ใช่
Reduce because it's less than 1, okay? 0.67 is less than 1, it's reduced. And the negative sign, the negative sign, it means that it is, the negative sign is for the orientation, okay? Negative orientation. Is it inverted or upright? Negative, it means on the negative y, on the negative y side, right? So therefore it's inverted, okay? It's reduced, inverted, and then real image, reduced and inverted, okay? So that is how we describe how do we describe the characteristics of the image using mirror and magnification equation. Okay, let us try this number 2. Number 2. Okay, assume that a certain concave spherical mirror has a focal length of 10. Okay, the same 10. Locate the image for an object distance of 5 centimeter. Okay, but DO is just 5 centimeter. Okay, so what you're going to do is describe the image characteristics. Okay, can you solve this one? Try solving in your notebook if you have your notebook there. So that is 1 over DI. Okay, follow me. Okay, help me so that we can have, let's see if we have the same answer. DI equals 1 over F. Okay, 1 over 10. Okay, and tell me if you have the answer already so we can make it faster. Okay, minus 1 over, what is that? 5. 5. Okay. So the LCD is 10, very easy. So 1 over DI is DI. Sorry, it's not negative. Okay, it's not negative. Is that my sign? Negative. Okay. Equals 10 is the LCD. And then what's that? 1 minus 2.
minus 2.
2 to make up. Okay, so 1 over DI equals negative 1 over 10. All right, so DI, the value of DI is, okay, what is the value of DI? Answer. Negative.
Negative 1 over. No.
DI is 1 over DI equals negative 1 over 10. So DI is negative 10.
10
All right.
Negative 10.
All right.
10 or
Negative.
negative 10.
Yes. Yes. Negative 10. And the unit is centimeter. Okay. Negative 10 centimeter. All right. So that is DI. Now, we're going to describe the image. So we need to solve for the magnification, right? So we have the value for DI, and then we have the value for DO, which is 5. So how do we do that? Negative 10. This is negative 10 divided by 5. What's the answer?
2.
2. All right. Positive or negative?
Positive.
Positive. Okay, so let's say that M is 2 times. Okay, 2 times. All right. So how do we describe the image? First, the type. Let us have the type. Is it real or virtual? Real or virtual?
How to look na teacher? Real virtual.
Okay.
I forgot that.
Okay. Let us go back. Take no. You can take a screenshot of this rule. Okay, this one, this rule. Okay, you can take a screenshot. This is the rule, or this is these are the rules. Okay.
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 Is
So
this real?
Okay, real if it is di is positive or negative real, right? Di is positive if it real image, if di is positive, virtual if di is
Visual.
negative. Okay, upright if the
Okay.
value of m is positive, it is upright. If the value of m is negative, it is inverted.
Invert. Okay, teacher.
Okay, let's go back to describe the image. Where's that? Okay, here. So what are the characteristics? Is it virtual?
Is virtual and upright?
Upright. And what about the size? Enlarged or reduced? This one, the
The
size.
size. Mm,
Greater than one. Sa make up, m is
Larger
greater
than
than one. So therefore,
enlarged.
enlarge. That is correct, Noina. Enlarge. Okay, so these are the characteristics. Okay, so virtual because it is on the opposite side, enlarged because it's greater than one, and upright. Okay, 2 times. Enlarged because it's 2 times. It's magnified, meaning it's bigger, 2 times bigger. Okay, and then upright. Okay, because it's positive. Upright because it's positive. Okay, that is how we describe. Now, let's say this is a convex mirror. If this is a convex mirror, what you're going to do, class, is to make F negative. Okay, based on that rule, F is negative for convex mirror. Chamikap, if you look at the rule. So therefore, if this is a convex mirror, you will have a different answer. Okay, because F will become positive. Okay. Now, I'd like you to answer this one. Okay, let us answer this. Okay, in your, let's have this as a quiz. Okay, 15 minutes. Okay, 15 minutes. Do I have another
my
example?
God.
Yes, let us have another example first. Okay, another example. A dime. Okay, a dime which is the height is 1.8 centimeter, meaning the size or the height of the dime, the object, is placed 100 centimeters away from a concave mirror. The image height is 0.9 centimeters and the image is inverted. Okay, what is the focal length? You're going to solve for the F. Okay, so these are the given. HO is 1.8. HI is negative 0.9, 0.9. Why negative? Because it is inverted. Okay. And then DO is 100, the distance of the object. So you're going to solve for F. Okay. How do you do that? You can use this equations. Since you're just going to solve for the F, just use the mirror equation. Okay, let's try using this one, same problem and same process. So how do we do that? First, we are going to solve for 1 over F equals 1 over DO plus 1 over DI. But since we don't have a value for DI, Jamaica, we don't have a value for the DI. So how are you going to do that? First, we can use this one to get the value because you can use this one, negative DI over DO plus equals HI over HO because we have the value for HO and we have the value for HI and we have the value for DO, meaning we can solve for the DI. Jamaica? Okay, we can use this formula. All right. So use this to find the value for DI. So what is the value for DI? Let's see first. Negative 9. DI is this is HI. HI is negative 0.9 and HO is this one. HO is 1.8 equals negative DI over DO is 100. Okay, so DI equals 50 centimeters. Okay, 50. So we now have the value for the DI. The DI is 50 centimeters. Okay, solve for F. Okay, type on the chat box your answer, everyone, please. 5 points for today. Today is September. What day is the day? 2, September 2. Okay, 5 points. Five points.
100 over 3, teacher.
Can you-
100 over 3. I don't know.
100 over 3. Not a
What?
fraction, please. Not a fraction. Okay, because we're going to
Oh my,
describe the
oh
image.
my God.
Not a
Okay.
fraction. Okay. Your answer, you can type in the chat box. So I can give you 5 points for today, everyone. 1 over F. I use this formula. DO is 100 and DI is 50. Solve for F.
Teacher 33.33. ใช่ไหม?
I don't
I'm not
know.
sure.
I don't know. How about the other students? Okay. There is one answer here. This is Noina. Okay. How about the other students? Not to everyone, Noina. Just message it to me. Your classmates can see it. Oh, no other answer? Only Noina? Okay, only Noina 5 points for today.
โ
Yay.
อ้โหดิเชอร์ thinking ก่อนไม่ได้หรือไงงานแป๊บ
Okay. Solve. If you have the same answer. Noina, erase your answer first, Noina. Can you delete your answer, Noina?
How?
How?
I don't know.
Unsend.
Is there only copy email? It can unsend. Sure.
Okay. My penray. Okay, my penray. Nakap. Okay, Fluke has the same answer. Fluke. Okay, so that's enough because we still need to solve for a quiz. Tungpang, Chukun. Okay, Tungpang and Chukun. Tungpang. Where's Tungpang? Pang, number 15. Okay, so we'll just check that. Okay, let's see if your answer is correct. Stop. Time is up now. Time is up. Time is up. Okay, so answer
It is 3 over 100.
100. Okay, so therefore that is 100 divided by 3 is
Yay.
33.3 centimeter. Okay, very easy. Okay, now just
Yay.
remember that if it is a convex mirror, everyone, you should make it negative if it is a convex, but concave mirror, make it positive. Okay, all right, quiz. Do you have a question?
don't
Very,
know.
very easy, right? You just need to follow this formula. Okay, you just need to follow this formula, and you have a screenshot already of the rules. Chamikap, you have already the screenshot. Okay,
Yes.
so in your notebook, please answer this one: number 1, number 2, and number 3. Where's that? Not that one. Sorry, not this one. Okay, problem solving activity number 1, quiz. Okay, number 1, take a screenshot. Number 1, please. Number 1.
Really
Number
hard.
2. Number 2, no, that's very easy, Noina. Okay, you just need to follow the mirror and magnification equation. Okay, number 2. Magnification. Okay, solve for the magnification. Okay, same problem with number 1. For number 1, you're just going to solve use the mirror equation. Number 2, you're going to use the magnification equation. Okay, take a screenshot, please. And number 3 is this one. Okay, for number 3, this is a convex mirror. Okay, a different. Okay, it means that F is negative.
Negative F.
Chai. Okay, convex mirror. Okay, solve please. Okay, so we have here Tungpang beam. Garto is present already. Okay, what about Zoom? Is Zoom present? Okay, solve. That's a quiz. Okay, quiz, and then type. I will make an album in our line group. You can solve that.
When is the deadline, teacher?
No, it's a quiz. Okay, we still have 12 minutes. Okay, that's very easy. 12 minutes.
Within this period.
Check up.
Okay.
Okay, for number one, again, for number one, calculate the image position, meaning DI, okay? 1 over F, the formula is 1 over F equals 1 over DO plus 1 over DI, okay? You're going to solve for the image position, meaning DI, okay? So number one, solve for DI.
Teacher,
Yes.
DO is 93 เหรอ
I cap 93 centimeters and F is 33 centimeters. Okay. And for number two, tell me, let me tell you number two so that for number two, same problem for number two, but you're going to solve for M. Okay. Magnification. And then describe whether it is real, virtual, upright, inverted, enlarged, or reduced for number two. Okay. So that is negative DI over DO. This is the formula for number two. Okay, and then describe the characteristics of the image, real or virtual, inverted or upright, enlarged or reduced. That is number two. And for number three, what you're going to do for number three is 1 over negative F, because it is convex mirror, equals